Okay, B3, estimating a derivative. There are actually really two different ideas in this one, but they're both kind of simple ideas. But we can talk about some stuff. I think it's a good spot to lead in and just kind of explain a couple important things about the test. When you guys take the AP test in May, there are calculator questions and there are non-calculator questions. There are twice as many non-calculator questions as there are calculator questions. So you don't have a calculator on a big chunk of the test. You do 30 multiple choice, then you get your calculator for the next 15 multiple choice. You keep your calculator for the first 2 FRQs, and then you lose your calculator for the remaining 4 FRQs. So it's calculator in the middle. Like, it makes sense. Like, get the calculator out, leave it out until you don't use it anymore. That's how it goes. Since the test is online, just like the SAT, just like not when you guys took it, but the Keystone test, they have a built-in calculator, and that built-in calculator is Desmos. Almost exactly what you see in Desmos when you just go to Desmos.com is just about what you get on the Desmos on the test. There's nothing that we would want Desmos to do that it wouldn't do on the test for us when we have it. So we're going to look at that. We'll kind of look at both, because you can do things with your calculator. You can do things in your calculator. You can do things in Desmos. We want to learn how to do both of them. So let's start out. Maybe we'll do one in Desmos and we'll do the other one in our in the calculator, so we can see both things. The first thing to understand, and looking at the title of this, the title of this is called Estimating the Derivative with the Calculator. The calculator does something similar to what we did in the very beginning when we were trying to find limits, where we were making tables and we're saying things like, this sure looks like the limit is 2. Does that sound familiar? Does that make sense? It doesn't do what we're going to learn to do. Our calculators don't. There are calculators that will do it. It's not saying like, oh, I know the rules to find the derivative of a polynomial. I'm going to find that derivative and then plug the numbers in. It's doing more like we're doing. It's taking 2 values really close together, throwing them into a slightly different difference quotient than we use. And then it does it, and it gets closer and closer until it's satisfied that it's got the right answer. Like, it's got to be like the numbers aren't changing very much as it goes closer. So it's got a little bit of a process there where it does difference quotients that are really, really close to your, the value that actually it's really close on both sides of what it does. I'm saying too much. So both our calculator and Desmos do it that way. So that's why we consider it estimating. It's usually really good. The more normal the function is, a polynomial, it's going to get right. You got to, sometimes with weird functions, it kind of does some weird things. But all of that is not anything that we need to worry about. So anyway, let's start. We'll do the first one with Desmos. So we've got the f of x is sine square root of x, and we've got to find the f prime of 2. So go into Desmos, and in your first line, type in f of x equals sine square root of x. There is a keyboard that you could pop up. There are also shortcuts, so I never use that. I just type in SQRT, and as I press the T, I get a nice square root bar. It's not happy with me for some reason. Oh, I do need to use parentheses around that. That does make sense. The square root does imply parentheses, but Desmos doesn't like it. That's actually good. I mean, if you caught what happened there, I looked at it and it wasn't graphing, and I had that little error triangle, and that's a pretty good explanation of what I did wrong. Use parentheses around the argument for sine. I can do that. And then I can get the f prime of 2. The slope of the tangent line, that actually kind of makes sense. That looks like it's a pretty flat tangent line there. This is telling us that it's not the spot where it's perfectly flat, but it is pretty flat around x equals 2. And here's an example. This is my function. I'm asking for the slope of that tangent line. On the AP test, as far as putting answers down, there's a hard and fast rule of how they grade. They grade the first 3 digits that you write down. You are allowed to round. You are allowed to truncate. That means don't round, just write what you see. And I think that actually makes sense kind of from their perspective. So if you decide, if you're that type of person that despite the fact that your teacher has said the entire year, don't write all those numbers down, that's silly. There are people like that. That's okay. And you write all those numbers down, the person reading your answer is going to see 0.055, 3 numbers after the decimal point. That's the correct answer, and they're going to give you credit. Okay. So you can, like that literally is the rule. So they stop at 3. If you write 7 digits, they don't care. You can even make a mistake here. If you wrote 0.055134 and you didn't write the other 4, 22, they only read to 3 digits. Make sense? This is an example. This is not an example of where it would round, but pretend that was a 9 there. The answer is 0.55 and 0.056 would both be okay. But again, in this case, 0.5055 is the only okay answer because it wouldn't be incorrect to round here. So round or truncate, and truncate because if you write this whole thing, they don't care what you've written after that 55. Both of those are good. All the numbers, 0.055, or if it were rounded, which it's not, 0.056. Make sense? Cool. All right. So let's, what was that, 0.055? 0.055. Do I have a calculator on this? Yeah, I do. It just doesn't show up. There we go. Okay, let's do the next one in our calculator. Actually, we'll probably do it twice. I'm going to do it just in one go, and then I'm going to show you how we can do it kind of in the style of Desmos. If you go into the second menu after you press alpha, so if you press alpha window, you get not a secret menu, that would be the wrong way to describe it, but you get a new menu of things. And inside of there, you have nderiv number 3, which stands for numerical derivative, which is just kind of their way of saying we're estimating here, like I said earlier. So if you go down to 3, you'll get a nice looking screen that kind of looks like what you were expecting to write. It will allow you to use any variable you want there. So we're going to use x because why not? So you'll notice it's using our other notation, the ddx notation. We could type that function in. So ln 1 over. I could use a fraction there. Maybe I will. I'd have to use parentheses. Fraction comes from alpha first button. And I'm assuming that you guys know most of that stuff. And don't need to get rid of that one because it's just multiplying everything by 1, but there we go. Now that looks right. And our x value is 1.3. Two examples, neither one requiring rounding. So the ddx of ln of 1 over 5 minus x evaluated at x equals 1.3 is 0.270. And we are learning a little new piece of notation here as well, that evaluate bar. Again, the answer 0.27 is a correct answer because the 0 doesn't need to be written. Add the 0 there, that's a correct answer. Write every last number in your calculator, sure, but they're only reading the first 3 of them. This is notation that we'll use throughout the year. Leibniz notation has the x value built into it. If you want to, Lagrange notation, the one we used on number 1, has the x built into it. Leibniz notation does not have the x built into it, so we have to use an evaluated at bar, which is a tall bar about the size of the problem, and then what you're supposed to plug in. Questions on that? It is possible to do this in the style that we did it in Desmos. You could put that function in to y equals. Oops. Clear. So I could have put in ln of 1 over, and I'm going to do this with a fraction, 1 over the quantity 5 minus x. Looks good. And then from the home screen, you actually have access to that y1. I could do alpha f2 ddx. And then right there for me. Over near the right on there's a vars button, and that actually lets you, if you click over to yvars, that will actually give you your y1. It's not the only way to do it. That's the long way to do it. I just remembered. But yeah, so this will do the same thing. I'm not saying this. I'm not saying that this is any. Oops, I've done it way too many times. Not saying this is any easier, but if you didn't have Desmos, if you were using your calculator to do something, and you had to find multiple derivatives all at the same or of the same function, this could save you some button presses. That's all. Yeah, that's in the vars menu. I actually think it's also alpha F4. The fourth button over is a little bit quicker access to Y1. Yeah, that's what I should have hit. Yeah, just knowing what your calculator does. Not saying it's better or worse. If I have Desmos open, it's just quicker and easier to just kind of plug f of x in and go from there. All right. Okay, so with that being said, your choice whether you want to use your calculator or you want to use Desmos. You find the derivative of that function, use good notation, and write the equation of the tangent line of that function at x equals 1.